Okay, we're going to work with mean absolute deviation. Okay, sounds a lot more confusing than what it really is. Okay, mean absolute deviation is just telling us, on average, how far away is your data from your mean. So it's kind of like showing how close together your data is. But in particular, on the average, how far away is your data from the mean value? Okay, so let's work through this. Pretend like we have 8 scoops of Raisin Bran. Okay, and we're trying to figure out like a sample of how many raisins are in each of those 8 scoops. Okay, so we got 1 raisin in 1 scoop. We got 2 raisins in another scoop, 2 in another. Okay, 4, 4, 4, and 5. Okay, so this is the number of scoops in 8 scoops of cereal. Okay, what we want to do first is figure out the mean, because we need to find the distance from the mean of everything. Okay, so the mean, you know how to do that. You add up all the data and you divide by the number of items. Okay, so we're going to add 1 and 2 and 2 and 2 and 4 and 4 and 4 and 5. We're going to get 24. Okay, and we're going to take that 24 and divide by the number of scoops. Okay, there's 8 of them. Okay, so the mean is 3. Okay, so the mean of the scoops, all 8 scoops, is 3. Okay, now what we're trying to do is find out the difference between every data value and the mean of 3. Or think of it as distance. How far away each of these numbers are from 3. Okay, so I'm just going to focus on one at a time. The 1, you may not need to go through all this computation, but 1 is 2 away from 3. You could subtract if you wanted. So that 1 is 2 spaces away from 3. I'm going to kind of keep track of my distances on this number line. Okay, these 2's, all of them are 1 away from 3. Okay, because 3 minus 2 is 1. Okay, so all of these 2's are 1 away from the mean of 3. Okay, these 4's are all 1 away from 3. So I'm just keeping track of the distances on this number line. Okay, 5 is 2 spaces away from 3. I could subtract if I wanted, or I could just look at it. Okay, so what we have here, we have all of the distances away from the mean of 3. Okay, 1 is 2 spaces away from 3. All of these 2's are 1 space away from 3. Okay, all of these 4's are 1 space away from 3. And this 5 is 2 away from 3. Okay, you get it? We're just finding the distances every number is from our mean of 3, how far away they are from 3. Okay, so that's the first thing you do, first 2 things you do. You want to find the mean, then you want to find the distance each number is away from your mean, and then you want to find the mean of all of those. Okay, we need to find the mean of all of these distances. Okay, so we're going to add the 2 and the 1 and the 1 and the 1, and there's 3 more 1's. See, do I have 6 altogether? And then we have the 2. Okay, so that's 3, 4, 5, 6, 7, 8. That's 10 divided by 8, because there's 8 numbers again. There's 8 distances. Okay, we're going to get 1.25. Okay, so that number, 1.25, is called the mean absolute deviation. Okay, so what that means, think about what we did. We found the mean. We found the distances that all of these numbers are from the mean. That's what the second number line was. And then we found the average of those. So what we really did is we found the average distance away from the mean. So this means, on average, all of the data points, on average, are 1.25 away from the mean. Okay, you agree that that's a pretty small number? Okay, 1.25 away from something is pretty small. So that's telling us the data is not very spread out. Okay, it's really close to the same thing. So we could say that it has little variation. Okay, do your best on the next problem. And please let me know if you have trouble with this. It's kind of tedious, but I think you'll get it.